March 24, 1941. Quonset Point Naval Air Station, Rhode Island. The George A. Fuller Company's engineering division examined a pile of blueprints spread across the conference table, calculations that would have to become reality in less than 2 months. The United States Navy had just issued an almost impossible order: create a portable building that untrained men could assemble in enemy territory using nothing but hand tools. Make it stronger than anything the British had fielded during the First World War, and do it all before summer. Across the Atlantic, the British Nissen hut had proven its worth for 25 years. 6 men with 4 hours of labor could put one up on a prepared foundation. The record, 1 hour and 27 minutes, was achieved by a seasoned Royal Engineers crew under ideal conditions. But the American military needed something faster, tougher, and more adaptable, something that would alter the very arithmetic of wartime logistics. What neither the British nor the Germans understood in 1941 was that American industrial philosophy was about to rewrite the rules of prefabricated construction. The difference between the Nissen hut and the soon-to-emerge Quonset hut would not be measured in inches or pounds, but in the revolutionary belief that speed of assembly outweighed tradition, that simplification surpassed complexity, and that any soldier with a hammer should be able to build shelter as easily as firing a rifle. The story of how America constructed a building in a single day while Britain required a week reveals more than engineering ingenuity. It exposes the fundamental divide between 2 industrial mindsets, 2 wartime doctrines, and 2 visions of what prefabrication could achieve. The British Nissen hut was born of necessity. In April 1916, Major Peter Norman Nissen of the 29th Company, Royal Engineers, began experimenting with semi-cylindrical shelter designs. As the Battle of the Somme approached, the Western Front demanded housing for hundreds of thousands of newly conscripted troops, and conventional building methods couldn't keep up. Nissen, a Canadian-born mining engineer and inventor, took inspiration from an unlikely source: the drill shed roof at Queen's University in Kingston, Ontario, which had featured a semicircular design that collapsed in 1896. Nissen refined the idea, realizing that a curved shape would deflect shrapnel and blast waves far better than right-angled structures. Between April 16 and 18, 1916, he built 3 prototype huts. His design underwent careful evaluation by senior officers, including Lieutenant Colonel Shelley, Major MacDonald, and General Clive Gerard Liddell. After the 3rd prototype proved effective, the model was officially adopted in August 1916. The Nissen hut was remarkably simple. Curved corrugated steel sheets formed the outer shell, attached to T-shaped steel ribs set 6 feet apart. These ribs were bolted to floor bearers with wooden purlins running lengthwise to support the panels. It came in 3 standard widths: 16, 24, and 30 feet, and lengths in 6-foot increments, most commonly 16 by 36 feet. About 54 steel sheets covered a typical hut. Inside, walls could be lined with extra corrugated metal or pressed wood, creating an insulating air gap. Wooden end walls held doors and windows. Construction required a concrete base, 6 workers, and around 4 hours. By the end of World War I, at least 100,000 Nissen huts had been produced. Major Nissen was promoted, awarded the Distinguished Service Order, and patented his design across several Allied nations. He famously waived royalty rights for the duration of the war, a gesture his company would repeat during World War II. Despite its practicality, soldiers found the hut uncomfortable, cold and drafty in Europe, stifling in the tropics. Early versions lacked proper flooring or electricity, relying only on small stoves for heat. Still, they were sturdy, reusable, and vastly better than tents. Production slowed between the wars but resumed in 1939. The Nissen inspired several successors, including Britain's Romney Hut and eventually America's Quonset Hut. The key innovation came when U.S. engineers asked a radical question. What if we eliminated the internal frame altogether? In March 1941, the George A. Fuller Company of New York received an urgent call from Admiral Ben Moriel, Chief of the Bureau of Yards and Docks. The Navy needed thousands of prefabricated buildings for new bases along the Atlantic coast and across the Pacific. These structures had to be light enough to ship anywhere, strong enough to endure hurricanes, and simple enough for untrained crews to erect with hand tools. Fuller, one of America's largest construction firms, known for the Flatiron Building, and the Lincoln Memorial, assembled a team led by architect Otto Brandenberger and engineers Robert McDonnell, Thomas Secondino, and Dominic Ergo. Their assignment: design a revolutionary portable shelter, build a production facility, and deliver finished units, all within 60 days. Using the Nissen hut as a starting point, they analyzed its strengths and weaknesses. The curved profile was structurally efficient, but its internal steel framework made assembly cumbersome. The Fuller team decided to preserve the shape but reimagine the structure, shifting complexity from the field to the factory. A vast manufacturing plant rose near Davisville, Rhode Island, in just 30 days. Confident in their approach, the WWII company began production even as engineers continued refining details. A hallmark of wartime American industry. Produce now, perfect later. The original Quonset design, called the T-rib model, was 16 feet wide, 36 feet long, with an 8-foot radius. Like the Nissen, it used T-shaped steel ribs, but the Americans improved on the idea. The ribs, made from 2 channel sections welded back to back, formed a serpentine groove that allowed nails to grip directly into steel. No bolts required. This innovation drastically reduced construction time. The outer shell was corrugated, galvanized steel curved by the Anderson Sheet Metal Company of Providence. The interior used masonite panels with paper insulation in between. Floors were tongue and groove plywood on a metal base. Each Quonset could sit on concrete, pilings, or bare ground. It cost about $800 to manufacture, roughly $12,000 today. Packed into a few crates, a 10-man crew with simple hand tools could assemble a complete hut in a single day. In June 1941, the first Quonset huts were shipped overseas to Britain under the Lend-Lease program, marking the beginning of one of America's most successful wartime engineering achievements. The British, who had invented the Nissen hut 25 years earlier, now received structures that could be assembled faster and provided better living conditions. By the end of 1941, approximately 8,200 T-rib Quonset huts had been produced. Early field reports from Iceland proved the design's superiority. A hurricane-force gale ripped the covering completely off many British Nissen huts and crumpled PBY flying boats on the beach like paper. The Quonset huts emerged practically undamaged. December 7, 1941, changed everything. The Japanese attack on Pearl Harbor brought America fully into World War II. The Army immediately ordered 16,000 Quonset huts. Demand would only accelerate as the war expanded across 2 oceans and 6 continents. But even as production ramped up, engineers identified problems with the T-rib design. The curved walls extended all the way to the floor, creating unusable space along the sides. Beds, sinks, washing machines, and equipment had to be moved inward, wasting valuable floor area. Additionally, some commanders wanted even faster assembly and lighter shipping weight. The Fuller Company developed the Quonset redesign model with 4 FT vertical sidewalls supporting a modified arch. This reclaimed floor space and made the interior more functional. The new arch assembled in 2 sections instead of 3, reducing erection time and the number of fasteners required. The modified design used an I-shaped steel member produced by Strand Steel, a subsidiary of Great Lakes Steel Corporation. Approximately 25,000 redesigned huts were manufactured at West Davisville. But Strand Steel, already established in the lightweight steel framing market, saw an opportunity to improve the Quonset even further. The company had showcased its residential steel framing system at the 1933 Chicago World's Fair in the Homes of Tomorrow exhibit. Now, Strand Steel engineers proposed taking over wet production and implementing their own revolutionary manufacturing system. In late September 1941, the Navy awarded Strand Steel a contract for Quonset production. Design approval came in October. Over the next year, Strand Steel gradually assumed primary production responsibility. By 1943, when the factory at Quonset Point was phased out, Strand Steel had become the dominant manufacturer. Otto Brandenburger remained project leader throughout the transition, but the design underwent a complete transformation. The Strand Steel quane reverted to the full arch shape, sacrificing some floor space in exchange for dramatically improved manufacturing efficiency and portability. The key innovation was in the steel ribs themselves. Strand Steel abandoned the TT rib entirely. Instead, they created ribs from two lightweight steel channels welded back to form an I-shaped member. Between the channels ran a serpentine groove, even more efficient than the original T-rib design. This groove allowed workers to use friction-held nails instead of bolts throughout assembly. The new ribs were 35% lighter than T-durs ribs and 60% less expensive to produce. More importantly, they could be fabricated in 2 sections instead of 3, with simpler splice plate connections. This reduced the number of pieces that had to be tracked, shipped, and assembled in the field. The Strand Steel Quonset measured 20 ft wide by 48 ft long. Despite being larger than the original 16x36 FTTR model, it weighed less and occupied less shipping space. The floor system changed from 1-in floorboards to half-in plywood. Lighter gauge galvanized siding replaced the heavier steel used earlier. The siding layout was modified so that only factory curved panels were used along the ridge line. The remainder of the hut used horizontally installed panels that could ship flat, further reducing transportation volume. When created, a complete Strand Steel Quonset required just 270 to 325 cub-feet of space compared to 450 cub-feet for their design model. This was less space than canvas tents with wooden frames required. The assembly instructions were masterpieces of simplicity. Lay out the floor framework and install plywood flooring. Position and bolt these steel rib sections together. Stand the ribs upright and bolt them to the floor framework at 6 ft intervals. Install the nailing strips between ribs. Nail the corrugated steel panels to the ribs and strips, starting at the ridge and working down each side. Install the interior masonite lining by nailing it to the ribs. Attach the pre-assembled end walls. Install doors, windows, and any interior partitions. Connect ventilation and heating systems if required. 10 men with hammers, wrenches, and basic hand tools could complete the entire process in 1 day. 8 hours. No cranes, no welding equipment, no specialized skills, just soldiers following printed instructions and driving nails into grooved steel. The Strand Steel manufacturing system transformed Quonset production from craft to industrial process. The Great Lakes Steel Corporation factory in Detroit operated multiple production lines simultaneously. Steel coils arrived by rail and were formed into channels by progressive stamping dies. The channels were cut to-length, paired and tack-welded to create the grooved ribs. Rib sections received splice plates and bolt holes in precise locations. Corrugated panels were sheared to size with some bent to their acquired radius for ridge installation. Plywood was cut for flooring and end walls. Doors and windows were prefabricated. Every component was designed for interchangeability and foolproof assembly. Compare this to British Nissen hut production. The Nissen required skilled workers to bolt dozens of connections between ribs and ploughland. Each corrugated panel had to be positioned precisely and secured with hook bolts. The straining wires had to be carefully tensioned to prevent structural spreading. Weather conditions affected bolt installation. Rain made steel slippery, cold made fingers clumsy. The assembly process was sensitive to crew experience and environmental conditions. The Quonset, by contrast, was remarkably forgiving. Nails could be driven in any weather. The grooved ribs automatically aligned panels. The I-shaped steel members were inherently more rigid than T-sections, reducing the need for supplementary bracing. An inexperienced crew might take 12 hours instead of 8, but they would still complete the hut successfully. The difference was philosophical. British engineering emphasized getting the design right and then training crews to execute it properly. American engineering emphasized making the design so simple that untrained crews couldn't get it wrong. The British optimized for skilled labor. The Americans optimized foreign skilled labor at scale. By 1943, the advantages of American methods were measurable. A Nissen hut required 6 men and 4 hours under ideal conditions with an experienced crew. A Quonset hut required 10 men and 8 hours with no experience necessary. This sounds like the Quonset took longer, but factor in reality. A typical Nissen hut crew after training could maintain the 4-hour standard about 60% of the time. Bad weather, crew fatigue, or difficult terrain easily doubled assembly time to 8 hours or more. A Quonset crew working in identical conditions might take 10 hours on their first attempt, 9 hours on their second, and reliably 8 hours thereafter. The Quonset's ease of assembly meant less variance, more predictability, and ultimately faster deployment at scale. More importantly, the Quonset required less skilled oversight. A sergeant with basic literacy could supervise Quonset assembly using printed instructions. Nissen construction required at least one experienced crew member who understood structural principles and proper tensioning procedures. In a rapidly expanding military with millions of newly inducted personnel, this difference mattered enormously. The statistics tell the story. During World War II, Britain produced approximately 100,000 additional Nissen huts beyond those built in World War I. The United States manufactured between 150,000 and 170,000 Quonset huts between 1941 and 1945, with the higher figure representing all variations including warehouse models. American production exceeded British output despite starting 25 years later, and did so while simultaneously building Liberty ships, tanks, aircraft, and every other implement of war. The Quonset huts went everywhere American forces went. They served as barracks in Iceland and the Aleutian Islands, weathering temperatures far below zero. They functioned as hospitals in North Africa and Italy. They provided offices and warehouses in England in preparation for D-Day. They housed personnel on Pacific islands from Hawaii to Okinawa. The Navy approved Quonset huts for 86 official uses, including barracks, chapels, isolation wards, latrines, bakeries, medical offices, dental offices, mess halls, warehouses, and repair shops. The largest Quonset hut ever built was a 54,000 FT warehouse on Guam. Technically designated as a multiple building, this massive structure used rectilinear steel frames with arched roof segments that could expand in both directions, representing an evolution of standard Quonset design. The standard 40x100 FT model earned the nickname Elephant Hut. These massive structures provided clear span space for aircraft maintenance and supply storage. Smaller 20x48 FT huts, called the Quonset 20, became the most common variant. The Pacific War showcased Quonset advantages most dramatically. Island hopping strategy meant establishing bases on coral atolls with no infrastructure. Everything had to arrive by ship. Construction crews faced tropical heat, torrential rain, typhoons, and often Japanese artillery. Speed mattered. Simplicity mattered. Durability mattered. Navy construction battalions, the famous CBS, became experts at rapid Quonset deployment. A well-organized CB unit could offload Quonset crates, transport them inland, prepare foundations, and complete multiple huts in a single day. The structures that rose from jungle and coral became symbols of American industrial power projected across 10,000 kilometers of ocean. The CBS developed specialized techniques for Pacific construction. On islands with suitable coral bedrock, they poured concrete slabs directly on leveled coral. Where soil conditions were poor, they drove wooden pilings or used steel frameworks to elevate structures above potential flooding. In areas subject to typhoons, they anchored huts with additional steel cables driven deep into coral or bedrock. The speed of CB construction operations astounded observers. At Tinian Island in the Marianas, construction battalions erected an entire airbase complex, including dozens of Quonset huts, in a matter of weeks. The base would support B-29 Superfortress operations against Japan, including the aircraft that dropped atomic bombs on Hiroshima and Nagasaki. Every maintenance hangar, every supply depot, every operations building that supported those missions began as crated Quonset components offloaded from cargo ships. At Guadalcanal, CBS constructed Quonset complexes, while Japanese forces still occupied parts of the island. Construction. Crews worked under sporadic artillery fire and nightly air raids, the ability to erect functional buildings quickly, even under combat conditions, provided American forces with logistical advantages that Japanese commanders could not match. While Japanese troops sheltered in jungle dugouts or makeshift structures, American personnel operated from organized facilities with electric lighting, proper sanitation, and weather protection. British forces continued using Nissen huts throughout the war, particularly in North Africa and the European theater. The Nissen remained a perfectly adequate structure. 6 men and 4 hours was respectable, but adequate was no longer enough in an era when entire air bases had to be constructed in weeks, and fully equipped divisions needed housing within days of landing. The contrast between British and American approaches appeared most starkly in North Africa. British forces in Egypt and Libya relied on Nissen huts supplemented by tents. Construction required skilled Royal Engineers detachments. American forces, arriving in late 1942, brought Quonset huts that ordinary infantry could erect. British commanders observed with interest as American bases materialized with remarkable speed. The German military watched Allied construction capabilities with growing dismay. German war production focused on weapons and vehicles. Prefabricated housing received low priority. German troops often lived in captured buildings, tents, or hasty dugouts. The sight of American bases with hundreds of identical metal huts, electric lighting, hot water, and organized layouts reinforced the impression of limitless industrial capacity. German intelligence reports from 1943 onward documented American base construction with increasing alarm. Luftwaffe reconnaissance photographs showed Quonset complexes appearing on Pacific islands in North Africa and England. German analysts calculated construction rates and extrapolated American production capacity. The numbers defied belief. How could any nation manufacture tens of thousands of prefabricated buildings while also producing aircraft, ships, and tanks in unprecedented quantities? The answer lay in American industrial organization. Strand Steel operated as one component of Great Lakes Steel Corporation, itself one division of a vast industrial network. The same manufacturing principles that produced Quonset huts applied to Liberty ships, aircraft components, and tank hulls. Standardization, prefabrication, assembly line methods, interchangeable parts. These concepts permeated American war production. The Quonset Hut exemplified the system, but was not unique within it. After the war ended in 1945, the Quonset Hut faced an uncertain future. Would these utilitarian military structures have any peacetime purpose? The answer came quickly. A desperate housing shortage affected the entire nation. Government estimates indicated a need for 3.5 million additional homes in 1946 alone. Returning servicemen and pent-up wartime demand created a housing crisis. The War Assets Administration organized sales of surplus Quonset huts at Port Hueneme, California. 811 Quonset huts were offered to World War II. See veterans. On the first day, 75% were claimed by 600 veterans. Similar sales occurred nationwide. Prices ranged from $295 to $1,000 per hut, depending on size and condition. Veterans could purchase a complete structure for less than the cost of materials for conventional construction. However, buyers faced the problem of transportation. Each hut weighed approximately 6 tons when disassembled. Rail shipping cost 32 cents per 100, though 6 veterans could pull resources for a discounted rate of 10.5 cents per 100. Many veterans hired trucks to transport huts to their land, creating an unusual sight on American highways. Once delivered, assembly remained straightforward. The same simplicity that allowed soldiers to erect huts in combat zones worked equally well for civilian veterans. A veteran with several friends could erect a Quonset in a weekend. The resulting structure provided more space than many apartments and cost far less than conventional housing. Universities acquired hundreds of Quonset huts for married student housing. The University of Iowa created Quonset Park, an entire community of curved steel structures. Yale University housed married students in Quonsets until well into the 1960s. Roger Young Village in Los Angeles became an entire community of Quonset Hut homes for veterans and their families. Named after a Medal of Honor recipient killed in the Solomon Islands, the village occupied land near Griffith Park. At its peak, Roger Young Village housed approximately 1,500 families in 750 Quonset huts. Life in Roger Young Village resembled small-town America transplanted into curved steel. Residents formed community organizations, organized sports leagues, held dances and social events. Children attended schools on site. Yet, residents understood the temporary nature of their housing. As veterans found jobs and saved money, they moved to conventional homes. By the mid-1950s, Roger Young Village had largely emptied. The site was cleared and redeveloped. Farmers purchased Quonsets for hay barns, equipment storage, and livestock shelter. Small businesses used them for workshops, warehouses, and retail spaces. Brothers Owen and Harold Bradley installed a surplus Quonset as a recording studio in Nashville in 1954. The studio, located at 84 16th Avenue South, became known simply as the Quonset Hut. Its curved steel structure created excellent acoustics that helped pioneer the Nashville sound. Patti Cline recorded Walkin' After Midnight there in 1957, followed by I Fall to Pieces and Crazy. Conway Twitty recorded his first hit, It's Only Make Believe, in 1958. Loretta Lynn recorded 5 albums at the studio, including her first studio album in 1963. Johnny Cash recorded his second studio album there in 1958, plus Ring of Fire in 1963, and Jackson with June Carter in 1967. Owen Bradley later became a producer and vice president for Decca Records' Nashville division starting in 1958. Columbia Records purchased the studio in 1962, and it continued operating as Columbia Studio B. But the Quonset quickly fell from favor as family housing. veterans found that the curved walls reminded them too much of military service. The standard Quonset 20 provided only 960 square feet of floor space, with much of it unusable due to sloping sides. This was too small for growing families in post-war America. By the early 1950s, most Quonset hut communities were being replaced by conventional housing developments. Yet the Quonset endured in other roles. Thousands remained in service at military bases. Many found second lives as farm buildings, where the clear-span interior and weather-resistant steel construction proved ideal for equipment and crop storage. Today, 70 years after World War II ended, Quonset huts still dot the American landscape, testament to engineered wartime construction standards. The Nissen hut story followed different trajectory. After World War II, many British Nissen huts were converted to agricultural or industrialists. Thousands housed post-war migrants in Britain, Australia, New Zealand, and other Commonwealth nations. 50 Nissen huts built as private housing in Belmont, North New South Wales. Australia became a unique residential community. 17 have been demolished over the decades, but the remaining 33 have been refurbished and remain occupied today. In Britain, scattered Nissen huts survive at former military installations, now serving as workshops, storage buildings, or historical exhibits. The Chiltern Open Air Museum displays a World War II-era Nissen hut with an authentic Royal Air Force briefing room interior. Some have been converted to businesses, demonstrating the enduring utility of wartime designs. The contrast between Quonset and Nissen hut design philosophies reveals broader differences in American and British engineering culture. British design emphasized elegance and efficiency within the manufacturing process. The Nissen hut used relatively few components. Its T-shaped ribs and corrugated panels were straightforward to produce. The design assumed that trained crews would handle assembly. American design emphasized simplicity at the point of use. Strand steel added complexity to the manufacturing process, creating grooved ribs that were more difficult to produce than simple T-sections. But this manufacturing complexity enabled field simplicity. The grooved ribs transformed assembly from a task requiring skill into a task requiring only effort. This philosophy extended throughout American wartime production. The M1 Garand rifle was more complex to manufacture than the British Lee Enfield, but easier for conscripts to maintain. American tanks used simple transmissions that any mechanic could repair. While German tanks had sophisticated but maintenance-intensive powertrains, American cargo vessels, the Liberty ships, were constructed using standardized parts and assembly line techniques that allowed production to reach as many as 3 ships per day at peak efficiency. Speed of delivery mattered more than elegance of form. The ability to train unskilled laborers mattered more than precision craftsmanship. Output volume outweighed the perfection of any single unit. These concepts, controversial when introduced, proved decisive in wartime industry. The statistics illustrate the philosophy of American mass production. Between 150,000 and 170,000 Quonset huts were built during 4 years of war production. Using a midpoint of 160,000, that equals about 308 per week, 44 per day, nearly 2 every hour, continuously for 4 years. No individual craftsman could rival that pace. No traditional building method could approach such scale. Modern prefabricated construction owes a profound debt to the Quonset hut. The concept of transferring complexity from the job site to the factory underlies everything from modular housing to modern arched steel buildings. The ribbed groove concept survives in contemporary techniques: metal studs that grip drywall screws through friction, or wall panels that connect without specialized framing skills. The rule endures: make the component smart so the worker doesn't have to be. Today, manufacturers across the globe produce Quonset-style structures using modern materials and processes. Contemporary models use galvanized steel with advanced anti-corrosion coatings and engineered framing capable of withstanding Category 4 hurricane winds and heavy snow loads. Yet the basic principle remains unchanged. A semicircular profile offers natural strength. Prefabricated parts ship efficiently. Assembly requires only simple tools. In Alaska, where thousands of World War II-era Quonset huts still stand, the design is so common that some municipalities restrict new construction to prevent overuse. Those wartime structures, thrown together under urgent circumstances more than 70 years ago, still serve as homes, workshops, and warehouses, a testament to overbuilt standards and durable design. The story of the Quonset hut is ultimately about industrial philosophy. Britain built a clever structure and trusted skilled men to assemble it correctly. America created a design so foolproof that even untrained men could not assemble it incorrectly. Both methods had value, but in a global conflict demanding rapid mobilization of millions, the American strategy proved superior. The difference between erecting a building in 4 hours versus 8 might seem trivial, but multiplied across thousands of bases on 6 continents over 4 years, it meant thousands of man-hours saved, thousands of soldiers reassigned to other tasks, thousands of buildings completed by crews who would have struggled with older designs. Speed of construction didn't win the war alone, but the capacity to project industrial power anywhere on the planet, to establish working bases on remote islands within weeks, to house and supply millions of personnel across dozens of nations. That capability defined victory. The Quonset hut was a small part of a massive industrial machine, but it embodied the principles that made that machine unstoppable. 10 men with hammers could build one in a single day. That simple truth marked a revolution in military engineering, a reflection of American manufacturing ideals, and a quiet but vital contribution to Allied success. The British Nissen hut had served nobly for decades. 6 men in 4 hours was impressive for 1916 technology. But by 1941, the world had changed. Total war required industrial-scale solutions. The Quonset hut delivered those solutions through a deceptively simple breakthrough. Make it so easy to assemble that anyone could do it. When we see a curved metal structure today, housing equipment, livestock, or small businesses, we're seeing the descendants of that World War II innovation. The Quonset hut proved that revolutions don't always come from exotic materials or advanced technology. Sometimes they come from asking a different question. Not how can we build this better, but how can we make it so simple that anyone can build it at all? In the end, that was America's true secret weapon in World War II. Not just the ability to manufacture more tanks, planes, and ships than anyone else, but the philosophy that every product, every process, every structure should be designed for mass production by ordinary workers and field use by ordinary soldiers. The Quonset hut, assembled in one day by 10 men with hammers, embodied that belief perfectly. It wasn't the most elegant solution, but it was the most effective one on the scale that mattered. The Nissen hut was good. The American Quonset hut was faster, simpler, and perfectly suited to 1941.